Hello, my name is Elizabeth Nagley, and I am a director with TNTP. I'm excited for you to engage with today's session focused on high-quality science teaching. In session 2, we're going to spend some time digging into how you can identify whether students have access to grade-appropriate science assignments using the TNTP Science Assignment Review tool from the Opportunity Myth. We will use what we learned from the last session to dive deeper into actual science assignments to determine if they are grade appropriate. When you leave the session, you will have the tools that you need to help you think critically about the work you're putting in front of your own students and how it aligns to future STEM career possibilities. To get the most out of this training, we ask that you first complete Session 1, What is the Opportunity Myth? Science Session 2 is our first content-specific session, and we encourage all science teachers and leaders who support science teachers to participate in this session. This session is designed to take approximately an hour to complete. Over the course of the session, I'll prompt you to pause the video to engage with resources through reflection and practice. I'll give you cues for approximately how much time to spend on each activity. Though feel free to move at your own pace and slow down to take as much time as you need to complete the activity before moving on. As you saw in Session 1, today's session there will be opportunities for you to engage with the content. When you see the orange folder symbol, you'll want to open the STEM.LD resource folder and access a document from that folder. When you see the blue light bulb symbol, you'll want to pause the video for written reflection. When you see the green pencil symbol, pause the video to engage in some practice. At the very end of the session, there will be a short survey that will record your attendance and completion of this session. For this session, you will need to open the Google Drive folder for Science Session 2. To open this folder, you can type in this web address shown on the slide into a browser, or use the QR code on the slide. Pause the video now to open this folder. Once you've opened the folder, resume the video to continue with the training. In our last session together, we shared the 4 key resources that influence a student's school experience and outcomes based on TNTP's study, The Opportunity Myth. For this session, we are going to focus on the first one, grade-appropriate assignments, specifically in the area of science. As you may recall from The Opportunity Myth, in our study, we found that students spent most of their time on assignments that were not grade level appropriate. And we also found that giving students access to grade appropriate assignments leads to a lot of growth, especially for students who start the year the furthest behind. So the question we aim to answer today is, how do we know if the assignments we are putting in front of students are grade appropriate or not? And that's what we will explore together in this session. Overall, the goal of this session is to deepen your understanding of what grade-appropriate work looks like in a science classroom. We will begin by exploring the framework and content of the Tennessee Science Standards. Then, we will take a look at TNTP's Science Assignment tool and practice using it to determine if assignments are grade-appropriate. Let's get started. As we've said, the TNTP Student Assignment Tool for Science can help us to internalize what strong assignments look like in a science classroom. You can access this Student Assignment Tool in your STEM.LD resource folder. Pause the video to locate and open this document entitled TNTP Science Assignment Review Protocol. After you've opened the document, resume the video. Now that you've opened the document, take the next 3 minutes to review the tool. Make notes of how it is organized and jot down any questions you hope to have answered by the end of the session today. After you have reviewed the tool, resume the video. As you've likely noticed, the tool is organized into 4 sections: content, practice, relevance, and student performance. In our session today, we will focus specifically on building our understanding of the content section of the assignment tool. Remember, the purpose of our session is not that you become an expert at using the rating tool, but rather that you can use the tool as a guide for your thinking when considering the content in the assignments you give to students. To understand if an assignment has grade-appropriate content, you must determine whether the assignment targets a grade level standard in an appropriate way. The first two questions in the content section ask us about the standards. First, does the assignment focus on one or more grade level science standards? And second, do all the questions and/or tasks reach the depth of the grade level standards? To answer those questions, we need to zoom out and ensure that we have a foundational understanding of the structure and design principles underlying the Tennessee Science Standards. The Tennessee Science Standards were written based off the recommendations from a report published by the National Research Council entitled A Framework for K-12 Science Education. This report shared 6 guiding principles upon which the standards were written. 3 of these will be apparent as we talk more about grade-appropriate assignments today. The first principle is that science standards should focus on core ideas and practices. This allows us to get away from the mile-wide, inch-deep learning that previous iterations of the standards called for. Instead, we can focus on deep exploration of important concepts and actually practice science and engineering. The second principle is the recognition that the standards must progress over time and give students sustained opportunities to work with and develop their underlying ideas. This allows students to appreciate the interconnection of ideas over years instead of over the course of weeks. And this third guiding principle calls out that science is not just a body of knowledge. It is also a set of practices used to establish, extend, and refine that knowledge. So what does that mean for our standards? Previous iterations of standards looked like this. They were primarily focused on us teaching students a specific set of facts and teaching students to use science practices discreetly, often apart from the content. However, we know that this separation of facts and practices is not how students will experience STEM in practice in college or career. Our standards now focus on the integration of practices, ideas, and concepts into meaningful learning for students. You'll often see diagrams like this. These diagrams represent the 3 dimensions of the science standards and show us the connectedness of the practices, content, and concepts. In a strong science assignment, we should see the integration of multiple dimensions within that one assignment. We should see more than just the memorization of knowledge. Instead, we should see the science and engineering practices and cross-cutting concepts supporting students in their understanding of content knowledge. The 3 dimensions of the science standards are shown here on the slide for you to review. As you can see, there are 8 science and engineering practices, 13 disciplinary core ideas that are further subdivided, and 7 cross-cutting concepts. Let's take a look at one Tennessee science standard to help us understand how the core ideas, practices, and concepts are integrated. Pause the video here to read this high school biology standard. Take 5 minutes to read the standard and then reflect on the questions you see on the screen. What are students expected to do to show mastery? Where do you see evidence of the 3 dimensions? After you've read the standard and answered these questions, resume the video. Now let's review the standard. What are students expected to do to show mastery of the standard? The expectation for the standard is here in the red box. Compare and contrast existing models, identify patterns, and use structural and functional evidence to analyze the characteristics of life. Engage in argument about the designation of viruses as non-living based on these characteristics. Where do we see evidence of the 3 dimensions? Let's start with the science and engineering practices. The science and engineering practice is found here in the blue box. For this standard, the science and engineering practice identified is engaging in argument from evidence. We also saw that same language, engaging in argument from evidence, within the standard itself in the red box. While this is one science and engineering practice that clearly connects to the standard, If we saw a teacher teaching to the standard, we may observe them using other science and engineering practices as well. What cross-cutting concept does the standard connect to? We can see that here in this green box. This standard is about the characteristics of life, which can be connected to identifying patterns. You can also see that the standard connects to structure versus function, which is another cross-cutting concept. What is the disciplinary core idea? You can see that here in the orange box. This standard is a life science standard and is connected to developing an understanding of growth and the development of organisms. When we look to determine if a science task is grade appropriate or not, we need to look for evidence of all three of these dimensions present in what is being asked of students. The three dimensions are also sometimes referred to as the instructional shifts in science. Let's take a moment to pause and reflect on these questions. How do these instructional shifts align or differ from how you learned science? How might this make teaching or learning easier or more difficult? Pause the video here to reflect on these questions. Take 3 minutes to jot down a few ideas. When you are ready, resume the video. Three-dimensional instruction is often different from how educators experienced science as students and may be different from how they were taught to teach science as new teachers. While shifting instruction in this way may be difficult in the beginning, it is imperative that students experience integration of these three dimensions to access STEM-related fields in college and career. Now that we've built our understanding of the structure of the Tennessee Science Standards, let's return to the tool to talk about how we rate an assignment on these questions, which focus on alignment to grade level standards. To rate on content, you'll ask yourself which standards the assignment focuses on, and whether the assignment gives students a chance to appropriately meet the demands of that standard. There are two tools you can use to help you assess a task for standards alignment. First, you'll want to have the Tennessee Science Standards ready so you can view the actual language of the standards. You can find a copy of these standards in your STEM.LD resource folder. Second, the Disciplinary Core Idea progression can help teachers see what different levels of understanding on key standards looks like at their grade level. This comes from Appendix E of the framework for K-12 science education. Pause the video here to locate and open both of these tools. Take 4 minutes to review each document. When you're ready, click to resume. We will practice with this assignment from an 8th grade classroom. Pause the video here to locate and open the document called Science Assignments to Rate in your STEM.LD resource folder. Then, take 2 minutes to review this assignment called Assignment 1, 8th grade Science. As you will see, the student materials are on the left and the directions are in blue on the right. When you've finished reading this assignment, resume the video. First, we need to identify which grade level standard the assignment is most closely related to using the Tennessee Science Standards. Before the answer is revealed, pause the video here to try to answer that question for yourself. Take 5 minutes to use the Tennessee Science Standards reference guide to try to identify the standard that is most closely aligned with this 8th grade assignment. When you've identified the most aligned standard, resume the video. Let's talk about what you found. If you tried to align this assignment to 8th grade, you likely may have chosen this standard because it is in the 8th grade and it is aligned to Earth and space science, and it mentions planets. However, the emphasis from this standard is on the formation of the sun and planets and the role of gravity in the motion of celestial objects. In fact, This assignment is more closely aligned with this third grade standard, which is on the properties of different planets. And therefore, this assignment does not give students an opportunity to work on a grade level standard. You can also use our other resource, the Disciplinary Core Idea Progression Matrix, to help you understand what grade level understanding should look like for this standard. Here we are working on building understanding of Earth and the solar system in the 6th through 8th grade band. We can see that the emphasis is on the role of gravity in the solar system. As you see on the slide, it says, the solar system contains many varied objects held together by gravity. Solar system models explain and predict eclipses, lunar phases, and seasons. We did not see evidence of this in the sample assignment, and for that reason, this assignment does not focus on grade level content. For this assignment, we've seen that the content does not align with the grade level standard and does not reinforce core ideas at the appropriate level of depth. It's important to keep in mind that we cannot consider the intent behind this assignment or how it might connect to future lessons. Perhaps the teacher is next going to connect the size of the planets to an exploration of gravity. We don't know, and therefore, when we think about grade level assignments, we take the task as is and cannot assume of where the unit might be headed. We know that not all lessons every single day will hit the full demands of the standards, and that's okay. What students need is regular and consistent access to grade-appropriate assignments so that they are on track to access a pathway to a college or career of their choice. There is one final question in the content section that we need to consider before giving the assignment an overall rating for content. Does the assignment require students to use reasoning to make sense of phenomena or solve a design problem? Let's talk about what that means. In this case, a phenomenon is defined as an observable event that occurs in the universe that we can use our science knowledge to explain or predict. Here are some examples of things that are and are not considered phenomena. Take a minute to read these over. Pause the video to read these examples. After you've finished reading them, click to resume. A phenomenon is a discrete event that unfolds over time. It is not easily explainable and it can be puzzling, either because it contradicts what you think will happen or because the scale is too large or too small to be visible. A phenomenon leads you wanting to ask and answer open-ended questions about it. Why and how? A strong science assignment should be placed within the context of figuring out or explaining a phenomenon. Look at this assignment again and ask yourself, does this assignment require students to use reasoning to make sense of a phenomenon or solve a design problem? Pause the video and take 1 minute to reflect on this question. When you are ready, click to resume. In this assignment, we see that students are making a visual model of the planets using information they found from a video and some websites. There is no real-world event that this is tied to, and students are not solving a design problem. Placing content within a phenomena or design challenge puts the assignments in context and allows students to use the science and engineering practices to investigate with purpose. Without phenomenon-based instruction, students are often focused on memorizing facts and are left without the opportunity to work with the science and engineering practices or cross-cutting concepts. Let's consider how this assignment could have looked if it was based in a phenomenon. Here are 2 examples of phenomena that students could have explored, which would have helped them to build their understanding of the disciplinary core ideas of this standard through a real-world example. Recall that this standard was focused on gravity and its impacts. First, students could have investigated king tides and explored why they occur. Or students could have also looked at the orbit of Halley's Comet and investigated what causes it to move in the way in which it does. Both of these would have given meaning and purpose to the task. Based on this evaluation, we would rate this assignment as a 0 for content because it does not provide students with access to grade-appropriate content and does not give students an opportunity to engage in phenomenon-based learning. Now let's practice evaluating an assignment for content with another example. This 7th grade assignment can be found in the same document in your STEM.LD resource folder. Pause the video to locate and open this assignment. Then take 10 minutes to rate the content of this assignment using the student assignment tool and the resources that we've previously explored. After you've rated the assignment, resume the video. Let's discuss the rating for content for this assignment. Overall, this assignment earned a 2 for sufficient opportunity. Let's take a look at each question. The first question asks, does this assignment focus on one or more grade level standards? This assignment aligns with 7.ls.1.6, which focuses on using evidence to explain the relationship between adaptations and the likelihood of survival. This was reflected in both the data that students analyzed and the reflection questions that they answered. The second question asks if the questions and tasks reach the depth of the grade level standard. If you checked the Disciplinary Core Idea appendix, you would have also seen that the core ideas of this assignment reflect those for this disciplinary core idea at this grade band. Finally, does the assignment require students to use reasoning to make sense of phenomena or to solve a design problem? Yes. This task was placed within the context of a phenomena that students were investigating, that of the different shaped beaks of birds found on the Galapagos Islands. For that reason, the content of this assignment is strong enough to earn a 2 for sufficient opportunity. Today we focused on the content section of the assignment tool to help us understand how we consider standards when looking at science assignments. You likely also noticed that the tool contains sections for considering practice and relevance. If you're interested in deepening your knowledge on strong science assignments, we invite you to review the rest of the tool and the resources that are linked within. While this 7th grade assignment that we just looked at scored well in content, it would not score as well on practice or relevance. So we invite you to explore that on your own. That brings us to the end of our time on grade-appropriate assignments in science. Let's pause here to reflect on our learning from this session. Pause the video and spend 5 minutes reflecting on these questions. What are the current strengths and gaps in your science assignments? How could you use this tool to make sure your students have access to strong science assignments? Resume the video after you've reflected on these questions. We invite you to share these responses with your colleagues who are also participating in STEM.LD. The next session is focused on science instruction, which will continue to help you to internalize a vision for excellence in science education. This concludes our session today on grade-appropriate science assignments. In our next session, we will further deepen our understanding of excellent science education through an exploration of rigorous science instruction. Before moving ahead, please take a minute to complete the attendance survey using the QR code or web address shown on the screen. Once you've completed the survey, you will receive a confirmation email confirming your attendance in this session. Thank you for completing this training. This concludes Session 2 on grade-appropriate assignments in science. When you are ready, please continue to Science Session 3.